Good Monday morning! Today we are going to explore standard deviation. Standard deviation is a statistical concept. We are going to talk about what it is, why it exists and what it's good for, and how to implement it. And we are going to do that in JavaScript. That is what we're going to talk about today. I am MPJ and you are watching Fun Function. I know that some of my longtime subscribers might be thinking, why statistics? Why a statistical concept? This is a programming channel. What? We are learning some statistics because statistics is the basis of machine learning. This episode is kind of like an alpha beta thingy. I want to do more episodes about data science because I think that we as programmers are moving into a future where we cannot get away with not knowing that. Data science, machine learning and analysis and all that kind of stuff is becoming more and more used in business, and pretty much all venues of software development is just growing more and more and more. And let me talk a little bit about why I think that is. Spotify is actually an interesting example in this context. When Spotify got started, some 10 years ago, they did some user testing, and they asked people what they wanted from a cloud-based music player, and people were at this point, they had these MP3 libraries with a couple of thousand songs, so that was their frame of mind. They said that they just wanted everything in a list. The problem is that if everything in a list, you would start scrolling from the top, like a little bit on A, where ABBA is and stuff, and then you will scroll, but the little cursor scrolly thing wouldn't even have moved because there was so much music on the service. When you have a million bajillion songs, like the old conventions of just displaying data straight up, it does not make sense. When I started using computers, I don't know exactly, like 20 years ago perhaps, everything was sort of very databasey. Like everything, all the interfaces were tables. It's kind of like everything breeds from Excel and databases because in computer science and programming, the tuple or the database row is a very useful form to think about data and to store data. It's basically how data is often stored. I mean, in NoSQL databases, it's kind of like these data objects, but they're still kind of sort of rows. So the interfaces 20 years ago, they were basically just a very thin layer on top of the data. It just showed you your files, your MP3 files in a music player like Winamp, and gave you some searchability things. You could put them in other lists and other tables like playlists, but in the end it was pretty much like showing you the data in a very unabstracted form. And this is well-meaning. It's meant to give the user as much power as possible and let the user figure out on their own what they want to do with all this data, and it gives you some data management tools as well. However, over time we kind of learned that this thinking might be problematic. The user doesn't really like spending time with your software. The user does not want to use software. When they are using a music player, they want to play a song that fits their mood, for instance, or in the case of a checkout, a shopping cart, they want to just, as soon as they have made their purchasing decision, they want to move as fast as possible from that point to the actual checkout and payment. And the more time the user has spent in that process, the worse off they are, and the more you have failed as a software development team. In a utopian world, the software just magically knows what the user wants and gives it to them, and the user really doesn't have to use the software or fiddle around with it at all. So, in recent years, we have more and more software that kind of learns and figures out and looks at data for the user and figures out what the user wants. Amazon started doing this with the shopping experience. It kind of started figuring out that if a user that bought this thing also bought this thing, and there is a big pattern there, you can kind of, when a user put something in their shopping cart, you can based on that data recommend them that they also put this thing in their shopping cart. Spotify has an extremely successful product called Discover Weekly, which is, again, yes, the list, but it is an automatically generated list that is based on your previous listening history in the last months or year, I don't know. It generates a list of recommendations for you that you will probably, with a somewhat high degree of probability, that you will like. And that you haven't listened to yet. There's no interface for Discover Weekly other than the user just doing what they do, and based on that data, Spotify generates this magical playlist for you every Monday. So there is this kind of movement in the software industry from this notion that instead of giving the user software that is kind of like a very powerful database where the user can do these lookups, we have software that does the lookup for the user. 20 years ago, the user was expected to do the data science and analysis themselves. And 20 years from now, I firmly believe that software is expected to do that job for the user. And that means that we, as software developers, need to learn data science. We need to learn how to do data analysis in our software, because that is what software will primarily be about. Don't get me wrong, there's going to be interfaces and apps and clicky things forever, but I think that a growing and maybe even majority part of software is going to be software like Discover Weekly or Amazon's recommendations or Netflix recommendations, the kind of thing that just, based on a big data set, figures out what it is that the user wants. And that is why you, as a developer, needs to start looking at learning data science. Okay, so what is standard deviation? Why do we want to use it? And I know that some people are getting antsy right now, like, oh, just show me how standard deviation works. But it is extremely important that you understand why you are learning something. Because if you don't, your brain will just start to, okay, be critical and like, why is he learning this? No, what? Stop doing this. I don't understand how this is useful. And your brain will start identifying this thing as boring. And when it's boring, you just lose all kind of motivation and you will not be able to learn it, or if you are, you will eventually forget it. It's extremely important to learn why. Okay, so what is standard deviation? Let's just... standard deviation is given a data set of points, like the example that we're gonna talk about today is the orders per day. So on Monday you had 10 orders, on Tuesday you had 13 orders, on the next day you had 20 orders, and so on. Imagine a data set like that. And so they differ from day to day, right? Different on Tuesday, different on Wednesday, different on Thursday. Standard deviation is the deviation from the norm, from the average in that data set. It's a number that describes how much the order number normally fluctuates during a time period. Okay, so let's draw this. On this scale here, we have orders, and on this scale here we have time. So in our imaginary e-commerce store, we have like 5 orders on on Monday, we have, say, 7 orders on Tuesday, we have 9 orders on Wednesday, and then it drops a little, and we have 7 orders again. And then here it goes up to 16 orders, and then it drops again to, say, 6 orders. Let's say that we want to, in our e-commerce system, we want to create some kind of alerting system when we see spikes like this. Partially because if you get a lot of orders, we might need to, the person planning staffing might need to be alerted of that, or maybe the drop is just huge and there might be some problem with the system or some internet connection thing, or you know, some bad news or whatever. We want to detect anomalies. And how do we write software for a thing like that? I mean, we could just hard code the values so that we kind of figure out we just do some back of the napkin calculation and we figure out that the average is kind of, I don't know, perhaps 4 or something. The average is here. And then we just do like send an email when the order amount per day goes like far enough from the average that it's strange. We must just write some number, but it doesn't really scale, because as the store grows and it varies from week to week, like absolute numbers will it's just gonna break down. And this is where standard deviation comes in. It is the average distance to the average. So like we figure out that the average distance from the average is somewhere here. Or let's say that it's here actually. This one. Disregard this line. So all of these are within the standard deviation, because like it's this distance from this line and this distance from this line. All of these points here, they are normal, but this one is considered to be outside of the norm, and thus we can trigger the alert. After every day, using the standard deviation, we can just calculate the average for the current time period, like say that the last 60 days, and we can see like how far the point, like the current day that we're checking, how far that is from the mean or the average, and we can then calculate the standard deviation and see if that distance is below or over the standard deviation here. So this one is okay because it's not too far away from them, but this one is, we know that, oh, it's over the standard deviation. This is suspicious. We should throw an alert. Oh, right. Let's see if we can implement this. And you might wonder, why is he suddenly wearing glasses? And it is because I shot this segment before, but I forgot to screen record the entire fucking thing. So I'm doing it again. All right. So let's first invent our data set. Let's call them orders, I guess, or like, yeah, let's call them orders. This is gonna be our orders per day. The first day on Monday, 3 orders. Tuesday, 5 orders. 7 orders on Wednesday. 8 on some other day. Perhaps 5 again, and then it's Christmas, so it's like a lot of orders, and then 8, and then 4. Okay, so the first objective, if you remember my crappy drawing, is to figure out the average number of orders per day, because without that we can't do anything. So let's first figure that out. So how do we figure out the average orders? I guess we need the total orders divided by orders, the number of data points we have, so orders dot length. I want a little bit of inline evaluation here, so I'm going to start Quokka. Quokka is a cool little plugin for Visual Studio Code that allows you to do inline evaluation, which is really good if you're doing screencasts like I do. So we see here that we have an error on this line, and total orders is not defined because, well, we don't have that. And the total orders is a bit wrong. We want the sum of the orders. And sum orders, how do we do that? We're going to use reduce, orders.reduce. If you are not familiar with reduce, I have a video on that topic in that corner or that corner or in the episode description if you're being confused. Reduce takes two arguments. The second argument is the sum that we are starting with, which is 0, and the first argument is a function which has a the first argument is the sum, which on the first iteration is going to be just 0, and then the second argument is the order that we are iterating, and I'm gonna call it x because I feel like I'm gonna be being an asshole today. That's why I'm using x, and it's going to be x plus sum. This is the most basic reduce operation, summing things. Oh, I've accidentally opened up the output terminal. Let's close that. And all right, so if I just remove this, no, yes, no. Okay, so in order to get Quokka to inline evaluate, you have to do this, then it inline evaluates. So that means that this is now 65, that's nice. Let's see if average orders works as well. I'm doing this little Quokka highlighting thing. It has to touch or it won't work. Splendid. All right, so now we have this line here. The next step is to figure out these lines here, which is the average distance from the mean, the average. Like what is the average distance from this line between all these dots? In order to calculate this average, we first need all the differences. So let's see if we can do that. I'm just gonna call it differences. And it's going to be orders. Going to use map. If you don't use map, I have a video on that too. You can check that out here and in the episode description. Map takes one argument, another function, which is it's sometimes called a mapper, sometimes called a callback, sometimes called a predicate. It's the same thing. It is a function that takes each item in the array and feeds it into it, and it returns something new, and then that becomes another array with the same with those new values. I'm just going to make a function here that doesn't transform anything, so I can illustrate this by saying like if I x plus 1, you see that all the numbers increase by 1. If I do a 2, all numbers increase by 2, and so on. However, that is just an example. What we want to do is subtract the average orders per day, which gives us these differences here. Remember, we are looking for the average distance from the mean. I'm just going to call it this average difference. I'm going to add that. And you know what? We now that we have this array here that we want to calculate the average of, and we have that exact logic because we do that on the orders up here. So we're already doing this here. So I'm going to break this out into a function. So I'm going to call this let array average, and it's going to be a function that takes an array. That array we're going to call this on. Gonna steal that. Bonk. And I'm going to steal this. Go there. That should do it. And then I can just, if we remember that this is 8.125, just going to replace that with array average of orders. And it's the same. Cool. I can just remove this then. Oh, this is a mistake though. It's going to have to be R there. Okay, now we can just do this. In order to get the average difference, we can just do average array. Oh no, array average of the differences. And that will give us 0. That's wrong. Well, this is a problem because all of these are differences. And the thing is, the nature of differences is that if we sum them all together, they are per definition going to be 0 because they negate each other. So what we want to do is that we want to basically remove the minuses here because we are interested in the distance of these things from the mean. So now have a look at this array, how it changes when I do another map and I pass in math.absolute. So you see here that it just takes makes a number into its absolute counterpart, which is basically removing the minus sign. Let me show you when I remove this here. See? Bam, minus. Now, yeah, so now it works. We have these differences here, they are correct, and the array average is also correctly calculated. It's 4.2. So now we have these lines. But now we are getting into the annoying part of this presentation, because what we're looking at here is almost, but not quite, standard deviation. To do the strict definition of standard deviation, we need to square all these numbers instead of absoluting them, and we will calculate the average, just like we did do here, but after we calculate the average, we have to take the square root of that average. So we square the differences and then average them, and then we square root them to unsquare them. The reason we need to do that is sort of because of math compatibility reasons with algebra. And I will go into that a little bit more later, but for now just go with me here, and we're just gonna do the squaring thing so that we know what we are doing before we talk a bit about why we need to do it. So let's first square this, and you just square things by multiplying them with themselves, and we let the standard deviation be equal to the average difference, or the square root of the average difference. Bam! And now we have the standard deviation. And now we again have this thing, these lines here, but we have it in the mathematically strictly correct way, which is called the standard deviation. Okay, I think that we can actually use this to check if something is an outlier now. Like, remember that we are writing this code in order to identify these outliers and do alerts for them. So let's figure out if something is an outlier. Let's go through the orders array, create a map of that, and for each order we're going to see how far it is from the average order. Let me just show that is displayed in line. And then I think that we can just subtract the standard deviation and check if that turned out to be more than 0. Yes! So you see that 3, 5, 7, 8, 5, 25, false, 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 true, false, false. So it has correctly identified 25 as the outlier. So you see that you can easily use standard deviation to detect anomalies in datasets like this. And you can use standard deviations for lots of things, but this is one of the many use cases. Standard deviation is one of the most common phrases or concepts that you will hear in data science. It's being thrown around a lot and it's very useful. But I also promised that we would talk a little bit why we have to do this. Like, why do we have to square this, and why do we have to then do the square root of this thing? It was so much cleaner to just do math.absolute. Like, from a programmer standpoint, this seems a bit nonsensical. This number also doesn't seem quite as clean. It feels... I mean, it absolutely works, but why? Why do we do this? Well, mathematicians are strange. Well, not strange, but they like relationships between numbers. I'm pretty new at this thing, so I don't exactly know what it will entail, but I can tell you that this thing here, the one that we call the average difference, actually has a name in statistics, and it's called the variance. Variance is a very useful concept in statistics. It has all these interesting algebraic characteristics, or so I'm told. I'm new at this, and it has that partially because it is squared. Squaring things it's very good when you're doing algebra. Making absolute numbers, it's very tricky to use that in algebra at all. Like, it just messes algebra up. And even though I don't know exactly what this will be used for down the line, I can make a parallel to something that you might know, and that is the Pythagorean theorem, which is the relationship between the sides of a triangle. Mathematicians has figured out that there is a relationship between the 3 lines of a triangle. So I don't remember which, I think it's with the side A squared plus the side B squared is always equal to side C squared. When you're first exposed to the Pythagorean theorem, it seems like an interesting novelty, but not more. But it's actually ludicrously useful because it can be used to calculate the distance between points and all kinds of interesting things, and then you can shuffle these around to figure out the distance even though you only know 2 points, and it's just it's pretty cool from an algebraic standpoint and very, very useful. And I trust the mathematicians that variance will eventually become very useful, and we will be able to use it for many things like that. But basically, it's because of the nice algebraic properties of squared numbers that we do this squaring and then unsquaring using the square root kind of thing. And that is all I had. We have explored standard deviation today. And then I had a long rant about why we need to learn statistics as programmers. And it's because I think that we currently delegate a lot of sifting through data and figuring things out to the user, but in the future we will be expected to do that for the user to a bigger extent, and to do that we need to know data science. Then I made a spectacularly crappy drawing where I showed a bunch of points in an e-commerce system, showed that we were supposed to calculate the average, and that the standard deviation are these lines that indicate how far on average data points in our dataset tends to stray. And then we can use those averages to figure out when some bloody outlier comes along, and we can create an alerting system for that. For instance, this is just one of the many uses for standard deviation. And then we actually did an implementation where we calculated the standard deviation of a given data set. We used map and reduce to do it, initially we did a simple implementation where we just made the differences into absolute numbers before creating an average of them. Then I explained that that was almost but not quite the strict definition of standard deviation, and then we did the strict definition where you do a squared version of each difference and then do an average of that, and then pick the square root of that number that you get out, and that is the standard deviation. You have just watched an episode of Fun Function. I release these every Monday morning, 0800 GMT. But if you don't want to wait until next Monday morning, you can check out this episode, which Google's machine learning worm that they have in their basement has determined is the correct episode for you to view right now. I am MPJ. Until next Monday morning, stay curious.